This is Shakil Ahmed. In this tutorial, we will discuss about random forest. Random forest is basically ensembling of many classification trees. We select different set of observations from our sample data, and we construct the different trees and repeat the process a large number of time, and then the predictions obtained from all trees are then averaged to get the final prediction using a random forest. So random forest can do sampling on both ways. It selects a set of uh, predictors or variables to build the model. At the same time, it selects the observations from the given data set and then repeat the process a large number of times. Basically, instead of growing a single tree from all data set, we grow multiple trees from sub-data and then average the predictions from all those trees. So we start with the stroke data again. We have the stroke status. We want to predict the stroke status of the patients with their demographic and other clinical characteristics. So let read the data, and then for random forest analysis, we need to install the scikit-learn and matplot library. We have already installed. We don't need to do this, I think. And then we need to import pandas, SPD, and then model selection to separate the data into training and test, and then a random forest classifier. That is the library we use from the scikit-learn ensembling library. That consists of different ensembling techniques. So then we will also import the accuracy score and classification report. This will provide precision recall and F1 score all for both categories 0 and 1, or yes or no. And then the confusion matrix, which tells the true positive, false positive, and true negative and false negative values. And then matplot library, we can find the a bar plot for variable importance and other type of display like heat map. We need matplot um, library as PLT, and then we also use Seaborn to make more attractive uh, visualizations. So we run this model, and then we have a data frame, and we are removing the ID, and then we selected these columns from our data set and converted these columns to dummy. Let's run, and we have X data excluding the stroke variable from the data set, and the stroke variable is the variable Y. So we can do this. It's not working. I think we need to convert the variable first to the it's giving an error of ID not found in axis. So we have basically dropped the ID from axis. We can just remove this and then check. I think it's not working. We need to again read the data, and then we can check. Now it's working, so we don't need to drop the ID. We can keep this uh, in the list. Later we can uh, use the ID as axis. So we are dropping the NAC in our features, and we keep the Y values corresponding to the X index, which are not which have which has complete data, no missing values. And then we have X train. Y we can divide the data into training and test part. For both X and Y, we keep the training test size as 25%. I will reduce it to 20%. And then the training part is 80%. And then we initialize the random forest as RF model, and then random classifier, and we need to set the parameters, n estimators, uh, and random start. And then we want to keep, if we want to keep balance, then we can keep at balance. This is basically the number of trees. You can grow more tree to get more higher predictive performance. And then run, and then RF model. This is our RF model, and we will fit this model using X train and Y train. And then we will get the predicted values of Y from RF model dot predict. We use X test and RF model dot predict probability probe A, that is used for predicting the probability. And we can see the predicted probabilities, and these are the values and the corresponding predicted probabilities. You can see. And then model evaluation. Now we need to evaluate our model based on the test data. We have already predicted the Y values and get the predicted probabilities. Now we will use these predicted values. We will compare these predicted values with the actual Y values, the classification we have in our test set. So we can get the accuracy score, and we can get the confusion matrix, and we can get the classification report. So let's see, this is the classification report. This is the accuracy. Overall accuracy is 95%, around 96%. And then it is basically predicting the class 0. This is the majority class, 96%, but no observation in the minority class was observed as the correct. So all of the accuracy is covered in this value, the precision. And then recall is 1 for 0 class and 0 for 1 class. This is also 0, and support is also 42, means 42 observations are supporting uh, this class. And then we can see overall accuracy, and then averaged, and then weighted average. And we can see the confusion matrix. You can see there is no predicted strokes. This is no stroke, and this is predicted strokes. And we had all the 42 strokes data in our actual case, but no one predicted in the predicted stroke status. So this model is not a good model, as uh, it has no ability to predict the stroke class. It is only predicting the non-stroke class. And we can see this using the heat map of the confusion matrix. We can see 1176. I think it should be renewed. It should match with the this class 940 0 and 42 and 0. Basically, we are just presenting this matrix in terms of heat map, and a darker color for the heat map represents the higher value and vice versa. And you can make the heat map using the SNS library, SNS heat map, and then the confusion matrix, and then annotation is true. And you can also set FMT and CMap. This is the color, and then uh, this is the C bar. We don't need any C bar, so we can keep it false. And then these are the X ticks, level for the X and Y. These are called X ticks and Y ticks. And the titles are predicted labels and true labels. These are the labels for Y axis and X axis, and this is the overall title. We can keep here, and then plot show, you will get the plot. And then the feature importance. Feature importance is a most widely used performance metrics. This basically tells us how each and every way, each predictors contribute to the in predicting the response. So which variable is more important in our analysis? We can check this using the feature matrix plot. You can see the feature importance score corresponding to all the variables included in the model. Age is more important score in predicting the stroke with zero point 0.3 variable importance. And you can see other variables important. The least, the work type and gender has no impact on uh, predicting in predicting stroke status. You can just run this command uh, using the basically feature importance PD series, and then the model you have run model. This is the model name, and then feature importance, and then index X train columns. Basically, we have used this variable in our training data, and then sort by values ascending order, means the smallest to the uh, ascending is equal to false, means smallest to largest to the smallest. Basically, we are writing in descending order. And then you can give the different things, and you can make a plot using type is equal to bar plot, and we are using the feature importance plot. So you can just click it, and then you can see the plot. And then we have some specific discussion on random forest. It's an assembly technique, and decision trees as base learner are used. We use bootstrapping and random subspace, as we have already discussed this. And then prediction aggregation and handling non-linearity. It is basically an interesting method that handles the non-linear relationship between the response variable and the predictors, and it also captures the non complex relationship between the predictors and the response variable. And it also tells the feature importance, and we can tell which variable, which predictor is more important in predicting the response variable. So that's all about the random forest. If you have any question, you can always write. Thank you.